When we're graphing a quadratic equation, when the leading coefficient a is a fraction, this one tends to be a little bit more challenging. The axis symmetry is still x is equal to 0. The only time the axis symmetry will not be 0 is if we have a b term, something like this. So if we had an equation like y equals 2x squared plus 8x plus 7, then our axis symmetry would change. The equation to find the axis symmetry is equal to negative b over 2a. So in this case, b is 8 and a is 2. So we'll just substitute our values. And then negative 8 divided by 4 is negative 2. And then that would be our axis symmetry. In this case, since we do not have a b, our axis symmetry is simply 0. One way of graphing this is by setting up our table. We should note that the denominator of the leading coefficient is 5. So we want to go up by increments of 5 for us not to have to deal with fractions. If we go by 1s or 2s or 3s or 4s, or anytime we're not going by multiples of 5, this would alleviate the problem of having to deal with fractions. When we plug in with the 0, we're left with negative 10. So that means our vertex is 0, negative 10. Now we'll plug in 5. We can plug in negative 5, but I feel like plugging a positive number is easier, so I'm going to plug in the 5. 5 squared is 25, a fifth of 25 is 5, 5 minus 10 is negative 5. Since this is negative 5, in our range value, it will also be negative 5 for negative 5. And then we'll do this again by plugging in 10. So once we substitute 10, we get a fifth of 100 is 20. 20 minus 10 is 10. So since this is 10, this also will also be 10. Remember, a parabola will be symmetrical. So as the left side rises, the right side will rise by that same amount. Now we'll substitute 15. Since that's 35, then the other side will also be 35. And now we'll substitute 20. And this will leave us with 70. Since that's 70, this will also be 70. But the way I prefer to do it is by using a step pattern. Since that's 5, my step pattern will be slightly different. Usually we would multiply 1/5 times the step pattern, but since we're going in increments of 5, that will change a bit. And we will be going in increments of not 1/5 but 5. And we will multiply the step pattern by 5. So now all we have to do is add 5, then add 15 to the negative 5, then add 25 to the 10, and then add 35 to the 35. And we get that. And I believe that's a lot faster than what we did before. Even in graphing, I'm going to start at my vertex. I will go right 5 up 5 from the vertex and left 5 up 5 from the vertex. Right 5 up 15 and then left 5 up 15 and connect. Once I graph, I may want to check my furthest point. So I will check the 10, 10. And if that's 10, 10, then that's 10, 10. If I was using my table to graph, then obviously I won't check. But if I was just going right 5, up 5, right 5, up 15, then check it with the table you have, and those should match. Thank you, and have a great day.